And go.
FRQ2, right? So here in FRQ2, the easiest part that I can pick out from all of these, part section A, B, or C, is literally going to be the first part, right? A1. Leo, relax. So, show the camera over there, Leo. Check him out.
Mr. Mini Herrera.
Herrera?
Isn't that our chair?
Oh, yeah. That's so funny. So, here we go, right? FRQ2. So, what do? Which part should I tackle first, right? So, let's read the problem. It says here, a team of scientists began studying the population of white-tailed deer in a large wooded area in 2005. In 2007, T2, there was 31 white-tailed deer in the wooded area, right? So, this T2 is the 2 years that happened between 2005 and 2007, right? So in 2020, T equals 15 years after 2005, there were 135 white-tailed deer in the population. The number of white-tailed deer in the wooded area can be modeled by the function D, which D of T equals A times B to the power T. So you're dealing with an exponential where D of T is the number of white-tailed deer during years T, and T is the number of years since 2005, right? So here we go. What should I do first? Easy part. A1. Create or write down the two equations, right? So you're modeling the two equations that you're going to use to be able to solve the rest of it, right? So here we go. What's my equation? So again, instead of D of T, I'm just going to use Y. All right, let's keep it simple. So Y equals A times B to the power of T. So in my first equation, I'm going to use my first point, right? So let me get all this info and just make it into points. My first point, my initial point, is going to be 2, comma, 31. Notice how I'm not even going to use the years, right? 2005, 2007, that don't really matter to me anymore. So the second point, I'm going to have 15, comma, 136, right? So time is your input and the deer population is your output, right? So here we go. How to create the first equation? So Y equals A times B to the power of T. So what's my Y, right? My Y for the first point is 31. So this Y gets replaced by, 31. And my T gets replaced by a 2. So that's the first equation. What about the second one? So the second one you do basically the same thing using, again, the equation given. So here, my Y is 136 equals, right? Equals, well, again, A times B to the power of 15, right? So, what happened, Leo? Stop it.
Go.
Leo just went all loud. So, here we go, right? So, literally, that's it for A1. You do that, you get plus 1. You get a point, plus 1 point. Right, so there's 6 again. Each FRQ, 4 of them. Each of them has 6 points that you could possibly get. You do that, you get a point. So now, in part 2 from A, right, it's telling you, well, solve it. What are the values for A and B? Like, what do I do here, right? So, if I could erase this right here, right, because we don't need this no more. And I'm just gonna uncircle this real quick, right? So I can just solve it here, hopefully. You guys are able to picture it, or you know what, I'll just do it over here. So I'm just gonna rewrite this real quick. 31 equals A times B power 2. 136 equals A times B to the power of 15, right? So now this is the first one, this is the second one. So what do? Well, how do I solve something like this? It'll be easy. If let's say, for example, this T was 0, right? This would obviously, anything to the power of 0, right? It's the 0 row, it would just be 1, right? And we'll just be left with the 8. But in this case, we have to do the algebra part. We have to. So how should I start this? Well, let's leave one of the variables by itself. I want to leave A by itself because A is by literally itself and B is being affected by the degree of 2. So this simplifies to 1. So I have A equals 31 to the power of e to the power of 2, right? So what do I do with this? You're going to take this and then put it into the second equation. So I'm going to have 136. Where's my A? Is this the one right here? So I'm gonna replace A by all this. So 31 divided by B squared times B to the power of 15, right? So how could I simplify this? Quotient rule for exponents right here. You have the same base, B, right? So what do I do if I'm dealing with degrees? We'll just subtract them, right? So B 15 minus 2. So that gives me B to the power of 13, right? So how do I need the B by itself? You get the 31 to be divided because you're multiplying here. So divided, this becomes 0. Oh, I'm sorry, this becomes 1. And then here we go. So now you have 136 divided by 31 equals B to the power of 13. How could I get rid of this power? Just multiply it by a fraction. So make that 13 be multiplied by 1 over 13, and you can do the same thing here, 1 over 13. So these just simplify to basically 1. So now I have 136 divided by 31 to the power of 1 over 13 right here equal to B. So the problem is, can I use a calculator? Yes, you can. This is FRQ 2. You're allowed to use a calculator. So I already went and already inputted this into the calculator, and if you notice here, here it is. Oh, it's this right here. 136 divided by 31 is to the power of 1 over 13 is just 1.12046. But again, you have to remember that the decimal approximation, it's 3 digits or 3 numbers after the decimal placement, right? So the 46, that little extra, those extra 2 numbers here, we don't really need them. But some of you guys had questions regarding, hey sir, do we approximate right now, like in there, and that do we use that second, do we use that approximation to solve for the other variable, A? The answer would be no. The answer would be no, because if you go here and try to, right, we solve for B. B was whatever B was right now. Right?
1.120.
What was it?
1.120.
20, right?
Yes.
So this one, yes, for sure. Because we have to do decimal approximation. But in order to solve for A, we're still not gonna approximate, right? So if I solve for A, if I come back over here to the equation, which is over here, right? If I plug this B value over here, A equals 31 divided by 1.120 to the power of 2. If I do this, you're gonna get it wrong. This would be wrong, okay? So, if I go back over here to the calculator, right, you're gonna notice that all I did, this section in blue, this number, I copied it and I pasted it here. Notice how it expanded, right? It expanded and gave me other numbers that I wasn't able to see here. Take a look at that, right? So do not approximate beforehand over here. Do not put 1.120, because if you do, you're gonna notice that, hey, these two are, well, different, right? If I lower the screen so you guys could see it, right? Here it is. Look, check it out. Notice how the same 31 on top, the square is the same, but the approximation made a difference. Okay, so just be very careful with that. That was a lot of issues that we had when we were practicing this. So just make sure that, yes, you approximate for B, the value, but then not for A. Continue to use the number that you were given by the calculator. So what is A? Well, A has a value of 24.69, and then this 5 makes this go to 3. So there it is. We have another point. That we got. So we have 2 points at this part A, right? So hopefully, I know this could be a lot, but hopefully you guys understand what I was trying to say here. So I'm gonna erase this real quickly, right? Let me erase it. So now, here we go. Right? Here we go. Part B. Use the given data to find the average rate of change in the number of white-tailed deer and deer per year from T2 to T5 years, right? So, here we go. A-Rod. A rock is basically y2 minus y1 over x2 minus x1. Simple, right? In the solutions, they have something that is way worse. I try to simplify it just to this, okay? So I need points. Where's my points? Whoa, didn't we already put the points? Can we just take these points and plug them in? The answer is, well, yes, right? So A rock, which is my slope, right? Let's solve for it. So what's my slope here? Y2. So the second point, Y2, which is 136, minus Y1, which is 31, over 15 minus 2. So again, you're allowed to use a calculator. So plug it into the calculator. If you plug it into the calculator, you're gonna notice here that that you're gonna end up with this 8.07692 right over there. I don't know if you guys can see it over here. 8.07692. So again, sorry, do I approximate now? The answer is yes. For slope, for this one, yes, 7, 6, and then if you wanted to, instead of putting a 6 here, you could also put 8.077, right? As long as you're between these two, you'll get the point, okay? So now we have our slope. What do I do now, right? What do I do now? I'm just gonna put the 8.077, right? What do I do now? Well, if you keep going for B2, now it's asking, well, time out. A rock equals to 8.077. If you leave it like that, you're not gonna get a point, okay? Why? Because you have to tell me what's happening here. So you have to put this into a sentence. So in order to put it into a sentence, instead of putting it down here, I'm just gonna put it up here, okay? The proper way to put this is gonna be the average. Literally just copying what the text, right? The average rate of change is 8.077 deer per year. And there you go, right? Technically, we're almost done. Just put it into a sentence. Just copy paste whatever the text is telling you, right? With that said, B2 is telling us to use that same average rate of change found in 1 to estimate the number of white-tailed deer in the wooded area, right, for T equals 19.
Go.
Sorry, I had to go steal cereal from Leo, right? T equals 19. So what do? Alright, so now instead of using the slope equation, I have to use the slope-intercept equation. Y equals mx plus b. Guess what? We already solved for slope. We have to solve for b now, because x and y, believe it or not, they're already given. We're allowed to use whatever point onto whatever point we want to use. We have 2 points. Doesn't really matter which one you use. So now, here we go. How do I set this up? Well, you're gonna use something called, I don't know if you guys remember, something called NSolve, right? So you're gonna be solving for the variable b. So if I use the first one, right, I have x and I have y over here. So my y is 31 equals my slope, which is 8.077, and it's gonna continue. You're gonna notice that I'm not gonna use the approximate one. I'm gonna use the actual value one. And I'll show you right now, right? You're gonna take this number and you're gonna multiply it times my input, which is, in this case, it's 2 plus, well, b, and just put comma b, because that's what we're trying to look for. So again, the same concept goes here. Notice how here I put the dot. What I'm really trying to say is that this right here. Notice again that this slope that I initially found, when I went and tried to find the value of b, I didn't approximate it. I approximated for the b1 part of the answer, right? But when I'm trying to find b, I don't approximate, right? Or it just depends, but I want you guys to get used to not approximating if you're gonna keep using that number, right? Just like we did in part A. In this case, the numbers were, earlier the numbers were different. I don't know if you guys saw them, right? With approximation and rounding, But in this case, if I approximate and if I round, you're gonna notice that, hey, like right here, 14.8462, 14.846. And it's basically the same thing if I could erase someone from part the earlier section, right? You're gonna notice that here you have these two right here, 31 equals 8.0, whatever decimals I got from here when I copied it, right? And over here I rounded, multiply times 2, plus b, comma b, right? So here, it wasn't a drastic change. But then again, I want you guys to get used to not approximating. Just copy the value beforehand, right? From the previous section. Just keep the actual value. Anyways, so, stop.
Go.
So, yeah, so just be careful with that, the approximation and all that stuff, okay? So now my b value, right? What was my b value? My b value was, do you remember?
14.846.
B value was 14.846, right? So now, if I go back, sorry about that. If I go back, now, what do I do, right? The question is, what do I do? So now we need to remember, you have to remember that you have a new input. The input is 19. I have an input of 2, input of 15. Now I need to find input of 19. So again, I'm gonna take what I found, right? And then now I have y equals, sorry, I was rewriting y twice. Y equals my slope, 8.077, right? Times my input, right, x, which is t, which is 19, right, plus my b value, which is basically the one I have here, 14.846. And now, well, guess what? Guess what happened? Now we're trying to find the output. So can I use NSOLVE again since we're allowed to use the calculator? The answer is, well, yeah, but instead of comma b, you're gonna put comma y. And if you do that, my output is gonna be
168.
d of t, right? Which is the same thing, right? D of t, and if I go back, right, just confirm, right? 168.308, right? And if you notice here, I did 2 parts right here. If you notice in the calculator, right, that's why it looks a little bit off. But if you notice in the calculator, NSOLVE here and NSOLVE here are basically matching, right? Here, I didn't approximate, right? I didn't approximate my slope. I didn't approximate my my b value, my initial value, right? And then over here, I approximated, just like I have it over here. And yeah, they both basically match. So again, I want you to get into the habit of not approximating, right? Let's just keep it safe, right? With that said, right, let's see if we're correct, right? So if you notice here, yeah, basically, right, 8.079, which was close to 8.077, right? It tells you here, like, check it out right here, right, for my A-Rock. And then, where else are we at, right? We said 168, right, with the decimal, but notice here, look, 168, right? For the final section, this one's the hardest part, because you have to continue working on it, like here. Let me erase all this real quick. You have to continue working, right? You have to read the problem, right? Figure out what is happening here and these type of graphs, right? So typically, most of them, with FRQ2, is going to come with 2 sections each, right? This one happened to have 3, right? And C1 only happened to have 1 part, right? Or I believe C1 does have 1, or C has 1 part, right? So just in case, right? I know the video is already long. The answers for these 2, I'm just gonna have them right here. You can take a look, right? Where is it? B3 is this little section right here. I don't know if you want to pause the video or whatever, right? And then C is right here, right? Basically, which one is the best scenario in C, in part C, right? Should I use the model at t equals 8 or t equals 23? Remember, our interval, what did we start off with? My interval goes from 2 to 15. That's our focus. So which one's gonna best model the scenario of the future deer population, right? It's something between 2 and 15. So I would lean more towards 8 rather than 23, right? Because that's out of our model, right? Out of our domain restriction. So if you read the problem, it's gonna tell you, you should feel more confident with t equals to 8 rather than t equals to 23. And there you go. Good luck.